Okay, so this is the product of the magnitude of two different vectors sine the angle between them. Okay, so the definition for cross product goes like this. We are saying it has to be the product of the magnitude of two given vectors sine the angle between them. And how are you supposed to write this one? Here this has to be written like A multiplied by B must be equal to the magnitude of A multiplied by the magnitude of B sine theta. So these two formulas, we normally use them if they ask you to say, can you calculate the angle between the two given vectors? Calculate the angle between two given vectors. Okay, now what if they haven't asked you about the thing to say, can you calculate, okay, let's say maybe they just ask you to say, find A cross B or A dot B. What formulas are we supposed to be using? We don't use these formulas. These two formulas, they only apply whenever they ask us to say, calculate the angle between the two given vectors. Calculate the angle between the two given vectors. And the most used formula to calculate the angle is this one. This one, it is also used, but it takes a lot of time for you to reach at the final answer. Reason being, here you must undergo a lot of processes or other procedures for you to just reach on the final answer. So, if a question has come like they're saying, if they ask you to say, find A dot B, again, okay, if this is your A, then B, they say A cross B. What are you supposed to do here? If the question has come like this, what are you supposed to do? I'll start from here. For this one, you have to know that most of the times, questions based on three-dimensional vectors, they like using the notations that I'm from giving you. They normally use notations that I'm from giving you. That is I, J, and what? And K. That is I, J, and K. So you are going to understand that for this one, there is a simple rule that we have to be following. For this one, there is just a simple rule that you need to be following always. What is that rule? Remember, we are multiplying a vector which is going to have three different notations or other axes. This can also be your axes. Even this one is going to have the similar what? Axes. And how do you multiply? We multiply the correspondings only. We multiply the correspondings only. The rule which applies here is that if you multiply the correspondings, I multiply by I. The component for I here, or rather X, has to multiply with the component for I on the other side. It is going to give us a similar answer if we say J multiplied by J. It will also give us a similar answer if we say K dot K, which is going to be equal to 1. Why am I writing it like this? This is because if you take maybe 2i, you multiply by 3i, you understand that 2 multiplied by 3, you are going to get 6. I on part of 2 and I on part of 3, if you multiply them again, you are going to get what? 1. So 1 multiplied by 6, it will give you what? 1. But if you say I dot J, we are going to get the same answer if you say J dot K. Also get a similar answer if you say I dot K, which is going to be equal to 0. That's why we normally multiply the correspondings only, because they are going to give us an answer. But if you multiply something which is having a different notation, you multiply it with another thing which is also having a different notation, you can't get an answer. Reason being, different notations, they always give you 0. They always give you 0. Okay, that is according to if the question has come like this. If a question has come like you have two different vectors, they ask you to find the angle, we have to use this one. Firstly, you need to find I dot B. If you come here, you are going to find the magnitude of A and the magnitude of B, you multiply them. The answer you are going to get here and the answer you are going to get there, you divide and you are going to find the cos in that case. For this one we normally use what we call Cramer's rule. Cramer's rule. How does Cramer's rule applies? Before I come to Cramer's rule, I want to solve a question finding the angle using this formula, and also how to calculate for A dot B. Okay. An example. The vectors A, which is equal to, or say I minus 2j plus 4k, and B, which is equal to 3I plus j minus 2k, are drawn on the x or y plane. Say calculate A. Now say A dot B, B the angle between vector A and B. Let me use this to show that we're dealing with vectors. Something like this. Something like that. How do you calculate? Remember, if you have a dot in between, they simply mean you have to be multiplying the correspondings only. We are going to multiply the correspondings only. And here the only difference between the cross product and the dot product. Under dot product, we are going to end up with the answer which is not going to have any component. We are going to end up with the answer which is not going to have any component. But for cross product, we are going to have an answer that is going to have all the three components again. It must have all the notations at the end of your calculation. But for dot product, you can't have an answer which is going to have the same notations. Why? Because they are going to be cancelled at a certain point. Okay. Alright, remember we want to calculate for A dot B. So A dot B, what does it mean? You are going to get the first angle for A. I'll write it on the first part. I'll say open bracket I minus 2j plus 4k. I'll say close dot open 3I plus j minus 2k. Okay, now what does it mean if I say you have to be multiplying the correspondings? It is very, very simple. We are going to multiply this by that, this by that, and finally this by that one. That's how we have to be multiplying these same things. And remember, if you multiply I by that one, I multiplied by I, you must get what? 1. K multiplied by K, we are going to get what? 1. J multiplied by J, we are going to get 1. But the coefficients has to be multiplied on their own also. Okay, so this is going to be equal to, if you say I multiplied by 3I, we are going to have I dot 3I. I'll close this inside. Here, it's very, very important if we keep on using plus to add all the components, because we want to end up with the answer which is not going to have any component. Then I'll say negative 2j multiplied by that. I'll say open negative 2j dot j. I close. 4k multiplied by that. I'll also add 4k dot negative 2k. So if you multiply like this, just multiply in a simple way by saying I multiplied by I is 1. 1 multiplied by 3, we are going to get what? Here we have to get 3. Here we are going to get negative 2. Because j multiplied by j, we are going to get 1. Using the a simple rule which is given here. I has to be given, has to give us the same answer if we say j multiplied by j, k, which is going to be equal to 1. But if we multiply the opposites, like if you say I multiplied by j, you are going to get what? 0. So we don't consider that. Hence, we just multiply the corresponding directly. Same applies to the issue of addition. If you are adding vectors, you add the correspondings only. So here, if I was to add a plus b, I would have added I plus 3 what? Plus 3i. Then this one plus that and this one plus that. We are going to get what? A certain answer which is going to have what? So this multiplied by that, we are going to get negative 8. So if we calculate on this part, we are going to get what? Negative 10. So 3 minus 10, the answer has to be negative 7. This has to be A dot B. You are going to get an answer which is not going to have any component. To find the angle now, you have to do what? You must use the formula which is going to be what? You say A dot B, it has to be equal to A B cos theta. Okay, so A dot B, we are from finding that A dot B has to be negative 7. But we need first of all to find the magnitude of A and the magnitude of what? And the magnitude of B. And how do you find the magnitude of A and magnitude of B? You are going to say, I'll start with the magnitude of A. Say A has to be equal to a root of, you come to the question which is here. We are having I, which is going to be 1 square, plus, you come here, we are going to get negative 2 square, plus, come there, 4 square. Meaning that A has to be equal to root of 1 plus 4 plus 16. So the magnitude of A has to be equal to what? It has to be equal to 21. Okay, you try to come to the magnitude of B. It must also be the same formula. So we are going to start with this one. I'll say 3 square plus, you come to the middle part, we have 1 square. You come to that one, we have negative 2 square. The magnitude of B is going to be equal to 9 plus 1 plus 4, and the magnitude of B has to be equal to, we are going to get 14. Now you get back to the formula because everything now has been found. So we have negative 7 here, we have the magnitude of B, we also have the magnitude of A. So it will be very simple for us to find the angle between the two vectors, reason being, that's what we are from doing. I'll just place negative 7 here, the root of 21, root of 14, I'll multiply this part, then I'll divide throughout so that I can make it to be something which is going to be in a form of a fraction. Okay. So remember, this formula can also be written like A, the magnitude of A, magnitude of B, cos theta will be equal to A and B. It's just one and the same thing. What is the magnitude of A? We said it has to be root of 21. Now say multiply by root of 14 cos theta equal to negative 7. If you want, you can divide throughout by root of 21 multiplied by root of 14 throughout, or if you want, you can firstly find the angle here, now divide. That's when you can find, you can find the answer here, then you divide throughout. That's when you can punch that one. So I'll start with the root of 21 multiplied by the root of 14. We are getting 17.146. So here we are having 17.146 cos theta equal to negative 7. So we are going to divide now throughout by 17.146. 17.146. I'll cancel this, or say cos theta has to be equal to negative 7 over 17.146, and theta is going to be equal to cos inverse of negative 7 over 17.146, and our theta is going to be equal to, so I'll say cos inverse of negative 7 divided by 17.146. I'll close. So I'm getting an angle as 114.1 degrees. Say 114.1 degrees. That's how we find the angle and how you multiply the vectors using dot product. That's how we find the angle and using what we call the dot product. Okay, let's try to look at what we call the cross product. How are we supposed to understand the concept of cross product? It is very, very simple for us to understand the concept of cross product. How? I will still use the same examples. I'll still use vector A, which is given as, let me try to copy down this. Okay, I think let me try to use this other paper. Okay, so for vector A, we are having, now we have I negative 2j plus 4. Okay, vector B, we have 3I, okay, plus j minus 2. Okay, so they can also ask you a question to say, can you find, okay, based on the same question which I'm using here as my example, this one which is given on this given part, this one, they can also ask you a question to say, can you calculate A cross B? A cross B. Okay, I want to take a good example based on this. So you have to be so attentive here, because that's what I'm going to do even on this given part. If you say vector C is equal to AI Bj plus C K, small letter C, then vector D is equal to, maybe I'll say D I plus E, J plus F K. like this. Then they tell you to say, can you calculate the the cross product? Calculate the cross product of C and D. They write like C cross D. What you should always be doing here, we normally use the principle of plus, minus, plus, as we are trying to use what we call Cramer's rule. Cramer's rule applies to both two-dimensional vectors and also three-dimensional vectors. How? It is very, very simple. For you to calculate using Cramer's rule three-dimensional vectors, you must make it in a form of a matrix, which is going to be in a form of what? 3 by 3 matrix. And how are we going to do that? If you check here, we have this one, which is the coefficient of vector D, that one and that one. Here we also have A, B, C as coefficients of what? The components from the vector C. So for me to come up with what we call three-dimensional vector, here we can't just guess to say this is going to be my three-dimensional vector. Why? It is very, very important by making it like this. I'll pick the components first of all by putting them on top using this principle which is here. Meaning that the first component must have must have a positive. So we are going to have I. The second component must have a negative, I'll say J. The last component must also have a positive. That is what we call C cross D. Meaning that if I start with C, I'll get the coefficients for every component here by writing them in the middle. I'll say A based on its what? Straight with what we call the component of that same vector. Then the middle part, I'll say B. The last part, I'll say C. Okay. I'll come to the last part now. This one, say D. That one, I'll say E. And this one, I'll say F. Okay. So this has to be written in a form of a matrix. This has to be written in a form of a matrix. Okay. So say equal to. How do you calculate now here? How do you calculate at this moment of time? Calculations here can be very, very simple. Calculations here will be very, very simple for us to understand. How? For us to understand this part, we are going to start cancelling the horizontal line on top and every line which is moving in the vertical path. What does it mean? In short, I'll do like this. I'll cancel this one. I'll hide this given line, or rather this given part, and also I'll cut this given part like this. Any number that has been cancelled twice, it must remain outside. Any number that has been cancelled twice has to remain outside. Then you are going to find the determinant of the remaining numbers that hasn't been cancelled. Then you are going to find the determinant of the numbers that hasn't been cancelled. What I mean here is this. If you check, if we cancel this part, like this, we also cancel this given part. The number that has been cancelled twice has to be this one. I'll put it outside. I'll say I. Then to find the determinant of the remaining numbers, what are you supposed to do? I will write in a form of a matrix again by saying something like this. Then what numbers haven't been cancelled? We have B, C, E, F. We are going to find the determinant for these numbers. I will come in the middle. I'm going to come in the middle part. I'll do likewise. I'll cancel this part. I'll also cancel the middle part. Forget about the part that I cancelled first in this line. Now you need to focus on the part that hasn't been cancelled twice. That has been cancelled twice, which is negative J. You have to put it outside. The numbers that hasn't been cancelled twice when I'm cancelling the middle part, you must put them inside the what? The modulus to find the determinant. So in this case, the numbers that hasn't been cancelled are these. This one. Remember, I'm cancelling. If you cancel the first part, you are dealing with I only. If you cancel the middle part, you're now dealing with the middle part. Forget about the part that you cancelled. This one is going to remain uncancelled, specifically these numbers. So this number, including this one and that one, hasn't been cancelled anymore. Why? Because I'm cancelling this line and the middle part now. So I'll say, what is the number which has been cancelled twice? This has to be negative j. So we're going to write it like this. So the numbers that hasn't been cancelled, we have A, C, D, F. Wow. Try to go to the last part now. Try to go to the last part. I'll do likewise again. This part is going to be cancelled again. Then you are going to cancel now the end part. So the number that has been cancelled twice is K. The numbers that hasn't been cancelled, as I'm trying to cancel this line and that line, has to be what? These numbers. This one, that one, and this one, including that one. And this is going to be plus K. I'll say, I'll write my A here. I'll write my D there. I'll write my B here. I'll write my E somewhere here. And now we are going to find the determinant. How do you find the determinant? For two-dimensional vectors, how do you find the determinant for two-dimensional vectors? Because this is a 2 by 2 matrix now. This has to be a 2 by 2 matrix. So we start by multiplying the diagonal. You come to the minor diagonal by subtracting. So I'll put my component outside. I say open. So B multiplied by F, we are going to say BF minus C multiplied by E, we are going to get EC. I close. So if these are numbers, they're going to subtract themselves and multiply by the component. Minus J, open. This multiplied by that, we're going to have AF minus D multiplied by C, we're going to have CD, meaning that in the middle part, you do likewise. If you get a negative answer inside, you are going to multiply negative J by the negative answer, you get a positive value. You come to the last part, K, this multiplied by that, A, E, minus this multiplied by that, B, D, close. Simple. That's how we find the 3 by 3 matrix by using what we call a cross product. That's how we do it. That's how we do calculate. Let's try to get back to these two vectors now. We try to get back to those two given vectors and we calculate now both the angle and the what? Their cross product using the same principle which I'm using here. Okay, so we have two different vectors. We have vector A, which is equal to I 2j plus 4k, and vector B is given as 3i plus j minus 2k. So I'll say A cross B, we're going to have, remember to put the components on top in a format of plus, minus, plus. We're going to have I minus j k. We can't even be including the signs to say you need to put plus blah 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 here. No. Okay. All right. Now we are going to write. I'll start with A. I'll just pick the coefficient for every component here, we are going to have 1, negative 2, 4 at the end. You come to this one, 3, 1, minus 2. I'll start doing the what job. I'll hide this, and also if I hide this, I'll also hide that one. The number that has been hidden twice has to be written outside, so I'll say I. Then I'll put the numbers that hasn't been hidden, I'll write them inside, which is negative 2, 4, 1, negative 2. I'll do like this. I'll just move the middle part. I'll take it to the middle. This one is going to remain the same. That's what I'm from doing even on the other part. So the part that has been hidden twice has to remain outside. I'll say negative j. Okay, so in short, the numbers that hasn't been hidden twice here, these are our numbers. We are going to have 1, 4, 3, negative 2 inside the what matrix. So we have 1, 4, 3, negative 2, say plus. Okay, I'll do likewise. I'll hide this part, and I'll also hide this given part. If you look like this, what are the numbers that hasn't been hidden twice, or that hasn't been hidden at all? I'm going to have negative 2 here, 3, 1. Okay, now we can calculate for what? For the determinants. Cramer's rule involves the issue of determinants. Okay, all right, so we are going to have I open negative 2 multiplied by negative 2, we are having 4. Then if you come here, 1 multiplied by 4, say minus 4. I'll close. Negative j, open, negative 2 multiplied by 1, we are having negative 2, minus 3 multiplied by 4, we have negative 12, plus k, open, this multiplied by that, we have 1, then minus, open bracket, 3 multiplied by negative 2, we have negative 6. I'll close like this. Here we are going to get 0i. Don't forget to put this. Very, very important. Okay. Inside, we are getting negative 14. Negative 14 multiplied by that, we are going to get 14j. 1 minus negative 6, we are going to get 6 here. 6 multiplied by k, we are getting 6k. So this is what we call a that has to be your correct answer. That has to be your correct answer. Okay, so someone can even ask a question to say, now, how do you calculate the angle using cross product? How do you calculate the angle using cross product? It is very, very simple. We have to write it in this format like what the formula was written previously. We're going to have something like this, cos theta. Right. So here where there is this, that's where you're going to put what in? This. 0i plus 14j plus 6k. You're going to put it somewhere there. But you have to be very, very careful. For you to find the angle here between two different vectors using this one, you must find the magnitude of A, the magnitude of B, and the magnitude of this. Then you are going to divide and you'll be able to get the final answer just like that. And you'll be able to find the answer just like that. Okay, let's try to calculate for the angle. We try to calculate for the angle. Right. So A cross B is equal to the magnitude of A, the magnitude of B cos theta. So what is A cross B? We are from finding A cross B as, okay, let me write it like this. I'll say A, sorry, I've made a very big mistake. For cross product, we have to be using sine theta. Okay, so what is this? This has to be something like this. We are going to have the root of, I think I remember we got 21 for this one, multiplied by root of 14 sine theta. This has to be equal to, okay, what answer are we going to have here? Here we have 0. Yes. I thought that maybe try to mute your microphone if you don't have anything to say, because hello. Okay, so here we have 0I plus 14J plus 6K. But you have to convert this one, find the magnitude for that same cross product. What are you supposed to do for you to find the magnitude here? I'll just say a root of, I'll start from here, 0 square plus 14 square plus 6 square, right? Calculator, say 14 square. Okay, if you put 0 still we are going to get 0. That's why I just go direct into punching 14. And say root of the answer. So here we are getting 232. That's what I'm getting here. What answer did we get on this given part after multiplying the root of 21 multiplied by square root of 14? I think we got 17.146. We got 17.146. So I'll say 17.146 sine theta. It has to be equal to, which is 15.232. You divide. Okay, so we are going to have sine theta, which is going to be equal to 15.232 over 17.146, meaning that theta is going to be equal to sine inverse of 15.232 over 17.146. Now close. Say sine theta has to be equal to, I'll just punch this direct. Say sine theta has to be 15.232 divided by 17.146. Close, and we are getting the angle as 62.6 or 0.7. That is the angle that we are going to have this moment of time, which is going to be 62.7 degrees. Okay, so that's how we do calculate these two things. If we're using sine, we're going to get that answer. Whenever we use cos, we also have to get that other answer, which we are from getting. Okay, just a bit. Okay. All right. So that's how dot product and cross product works. That's how dot product and cross product works. We use these formulas whenever you've been asked to say calculate the angle between the two given vectors. So in short, if they ask you to say, can you calculate A cross B using cross product on two-dimensional vectors, you have to include the third component. We know that two-dimensional vectors, they just end in, maybe you can have something like this. So you can't cross multiply using the Cramer's rule, whereby you have two vectors, two components only. You must add another component here. You are going to write it like 0z. So if you've also been given another one which is having a missing component, that same missing component, you have to write it by putting 0, then you write z just like that. Okay.